Our next lesson is solving linear systems by substitution. So, in my personal opinion, this is one of the most important things that you do in Algebra 1. Some of you did it last year, so if you did, hopefully it will be a little bit easy this time. If not, that's okay. It's a tough section, so just do the best that you can if this is the first time learning it for you. And I think many of you will like this method a lot more than graphing, because you'll get an exact answer. You'll be able to tell if your answer is right away, whereas with the intersections it was a little bit difficult to tell. So we're going to go straight into an example. I'm going to ask you to solve this system of equations. And when I ask you to solve something, in systems of equations, if you start off and your equation has an x and a y, our goal is to, when we're solving, our goal is to get an x value and a y value. So it's important when you're doing problems like this that you know what your answer is supposed to look like. So we're supposed to have an x value, we're supposed to have a y value. If you only get an x or you only get a y, that means you didn't do as many steps as you need to. So first step for this type of problem is always going to be to solve either of the two equations for x or y. I don't care if you do the top equation, I don't care if you do the bottom equation, just do whatever one's the easiest. And what I mean by that is you need to get x equals something or y equals something. So what I want you to do is look at the two equations that we have in our system up there. See which one would be easiest to solve for x equals something or y equals something. So I'm hoping that you said that you thought that the bottom equation was the easiest, because that one's already done for you. So that one's already done. And oftentimes when I do a test or quiz on this, I'll usually give one problem where it's already done for you, so you don't actually have to do any work. However, there's going to be other ones in the future that you will have to do more work. So our second step is the hard one in the problem. This is the one where people always get confused. So for this one, we're going to substitute the expression from step 1. Remember, step 1 was already done for us. And we're going to substitute that into the other equation. So this is generally, I've noticed, this is the place where people tend to mess up the most. So what I mean by the expression from step 1 was we had this right here. We had x equals this stuff. So what I'm going to do now is I am going to take that 2y minus 3, and I know that that's equal to x. What I'm going to do is I'm going to put it into the x in the other problem. Do not put it into the y unless you have it as y equals. So in this case, I have x equals that. So it's going to go substitute in for the x into the other problem. So what's going to happen now is I have 3, but now my x has become 2y minus 3. The other mistake that people tend to do is they lose this poor 7y in the problem. So make sure that you don't lose anything when you're doing that step. It's really important that you don't lose that, because otherwise you're going to get the whole problem wrong. You'll get ugly fractions most likely. So let's go ahead and do step 3, which once you're done with step 2, step 3 is not too bad. So step 3 is you are going to solve for your variable. And in this case, we're solving for y because that's the only one that's left in our new equation. So if you remember from when we first did equations, our first step here is to simplify everything that is on our left side. So I'm going to simplify this by using the distributive property. So we're going to distribute. We get 6y minus 9 minus 7y equals negative 14. Our next step is going to be to combine like terms. So my like terms are my 6y and my minus 7y. That gives me negative 1y. You can write it as negative y if you want to. For the sake of this problem, I'm just going to write it as negative 1y. I bring down my minus 9, and I get that it equals 14. Now the problem has gotten a little bit easier. Slowly will get easier, but you do have to do a lot of work before it does. The next thing I'm going to do is I'm going to solve this problem out by adding 9 to both sides. When I do that, I get negative y, I'm going to write it over here, or negative 1y equals negative 5. In the end, I would have to divide both sides by negative 1, and my answer for y is 5. So that's my first part of the problem. Unfortunately, like I said, that's my first part of the problem. I am not done. Remember when I said in the very beginning of the problem, our goal is to get an x and a y. So now we need to go back and we find the x. So step 4 is going to be to find the other variable, in this case it's the x, using your original equation. So using the equation from step 1, the one that we solved for. So in step 1, we noticed that we had x equals 2y minus 3. That was my equation. So now I know, based on what I just got in my previous step, that y equals 5. So what I'm going to do is substitute in 5 for y. I end up getting that x equals 7. So my answer is going to be, there's two ways I can write it. I can either write it as a point, 7, 5, or I can write it as x equals 7, y equals 5. Either of those two is an okay way to write the answer. So now, if you are taking a test or a quiz or a final exam, I highly recommend that you try to check your answer. If you don't care if your answer is right, you don't have to, but I'm assuming that you do care, especially if you're on a big test or quiz. So when you check your answer, what you're going to do is substitute it back into your equations. You'll find that it should always work for the one that you had from step 1, the one that you solved for. But just to be safe, I think it's a good idea to check it into both equations. So for my first equation, I get 3 times 5 minus 7 times 7. Oops, I made a mistake. So I get 3 times 7 equals 7 times 5, or minus 7 times 5 equals negative 14. That gives me 21 minus 35 equals negative 14, and I will actually get a true statement there. So I'm good for that one. Just to be safe, I'm going to check the other one. So in that one, I get 7 equals 10 minus 3. I know that that's true, so I am good. I know that one's right. So if you're feeling pretty good about this, you can feel free to just pause this one and try it on your own. So I have 4x minus 3y equals 25. Y equals 6x minus 13. So go ahead and pause and try it on your own, and then I'll work it out. Okay, so for this one, luckily, I have the second equation solved for a variable. It is solved for y. So what I'm going to do is I'm going to take this stuff I have for y, substitute it into the other equation in the y, and for the y. Make sure you don't substitute in the x because it's y equals, so it's going to go in for that y. What's going to happen is I get 4x minus 3 times y, which is now 6x minus 13, equals 25. So that is definitely the hard part of the problem. Hopefully you got that part. If you didn't, that's okay. The only other place that people tend to make mistakes on is this part with the distributive property. So we're going to distribute the negative 3. That is going to give us 4x minus 18x. Make sure you don't forget to distribute the negative. We get plus 39 equals 25. We continue solving and get negative 14x plus 39 equals 25. If I keep on going, I'll get negative 14x equals negative 14. That gives me x equals 1. Now I'm going to take the x equals 1, substitute it into that other equation, the second equation, the one that I had solved for y. I get y equals 6 times 1 minus 13, or y equals 6 minus 13. That gives me the answer of y equals negative 7. So if you go back and you check your answer, you will find that the answer 1, negative 7 will work out. Sometimes if you're on a test or quiz, or even just doing your homework, you can actually look at the original problems and just think about it in your head and make sure it works out. That usually is enough for me. Although if you're new to this stuff, or if you notice yourself making a lot of mistakes when you practice, I recommend you write it all out just to help yourself. So we have one more type of problem. I'm still going to ask you to solve. This one is a little bit harder. And as with the last one, if you are feeling like you understand this really well, feel free to pause and just work this problem out on your own. However, there is an extra step to this one. So the extra step is that we need to start by getting a variable by itself. So you can either choose to get this x by itself, you can get this y by itself, you can get this x by itself, or this y by itself. So the important thing is that you need to isolate the variable that's easiest to work with. Otherwise, you're going to drive yourself crazy. So I'm actually going to choose the easiest one, which is this y, because there's no coefficient. So you're isolating that y. So we're going to solve for y. So when I solve for y, I'm going to write step 1. I am going to subtract this 2x from both sides. That should be negative. I end up getting y equals negative 3 minus 2x. Make sure you're okay with your negatives. Don't lose. Remember that the 2x is positive. In order to move it over, you have to subtract it. So now I'm going to do all of the same steps that I had in the previous thing. I always like to rewrite my two equations. So my original one was 4x minus 2y equals 14. The 2x plus y minus 3 has now changed to y equals negative 3 minus 2x. So I recommend that you rewrite both equations as you're doing it, because otherwise you might accidentally mix up the equations and it'll be a whole mess. So what I'm going to do is I'm going to take this negative 3 minus 2x. I know that's equal to y, so I can take that and substitute it into the y in the other equation. When I do that, I'll get 4x minus 2 times negative 3 minus 2x equals 14. Then I'm going to solve it out. I get 4x. If I distribute my negative 2, I then get plus 6 plus 4x equals 14. I'm going to combine my like terms, which gives me 8x plus 6 equals 14. I end up getting 8x. If I subtract 6 from both sides, I get 8x equals 8, or x equals 1. Now, continuing on to my final step, I am going to take this x equals 1 and substitute it back into my original equation. So the original equation I had was this one right here. You can substitute it back into the one that you have up there. However, you'll notice that the one that I have circled in yellow is much easier. I just gave it a star because it's a happy equation. It's much easier to work with because it's already solved for y. So then I'm going to substitute in for that one. I get y equals negative 3 minus 2 times 1. In the end, my y value is going to be negative 5. And I do recommend that you go back and check to make sure you got it right. You will find that it will check out and work in the end.